Hey everyone. Okay, so today we are going to be on page 163 in your books for practice 2, problems D, E, F, and G. Okay, but before we do that, I want to quickly review surface area and volume. What are they? How are they different? See if you can stop this video and think to yourself, what are the differences between the two? Okay, so for the surface area, we're looking at the area that's on the outside, and the volume measures the space on the inside. Examples for both of these, well, imagine that I have a bunch of posters that I want to hang, but I need to ship them, maybe to a friend, or I'm moving, and so I need to ship them somewhere else. And I want to know how big to make my shipping container. This will tell me the space that I need, all of this area, right? So I'm measuring the exterior, the outside. The volume example here is going to be one of space inside. So imagine that I have a glass and I want to fill it with water. So the volume would measure the space inside of the glass. So how much water can I fit inside it until I get to the top and it starts spilling over? Okay, so volume is space inside, surface area is the outside area. So what I'm going to do is give you two partially completed equations, and what I want you to do is stop the video and see if you can find out or remember what goes inside of each of these three blanks. Here, here, and here. Okay, stop the video and write it in. Are these the answers that you gave? So remember that this one, when we're measuring the surface area, we have two circles that we're looking for the area for. This whole thing is the area of both circles, but this part here measures the area of one circle. And remember, the 2 is because we have 2 of them. Now here with this second part, this is our cone right here, or this is like the body of the cylinder. And remember that this pi 2r, this is how we measure circumference, or the distance around the exterior of the circle. Okay, so then when we're looking here at my volume equation, that here I'm measuring the area of one circle, and I'm multiplying it by the height in order to get my volume. Okay, so these two equations are very different and they measure very different things. Remember that your answer for these will be some unit. Your unit can be centimeters, meters, kilometers, whatever it is, but remember it's going to have an exponent of 3 because we're measuring in the 3-dimensional space. And then for this, your answer is going to be in units squared. Okay, so meters squared, whatever, kilometers squared, because when you're measuring area, it is in 2 dimensions, just like this piece of paper is 2-dimensional, okay? Area is 2-dimensional. All right, let me take a quick pause, get ready. Sorry, what I meant to say before I did the quick pause is that we are going to be working with a volume today, not surface area. That's really all that I wanted to say before I move on. Okay, so let's get back to it. We are on page 163 with practice 2, and let's start with D first. Okay, so here I want to look and see what information I have. Well, I don't have a radius right now, but I do have a diameter, which is 8 centimeters. And I know that my radius is always half my diameter. So my radius here is 4 centimeters. Just so that way I'm not confusing myself, I'm actually going to erase this. I don't need it anymore. Okay, and lastly, my height. It is still height even though it's turned on the side, so this is 10 centimeters. Do you remember the equation from the prior page? What is the volume of a cylinder? Pi r squared times h. So here we want to plug in the values that we have, brackets around the 4 whenever we substitute values. Remember when we're using BODMAS, when we're just simplifying terms, and we want to take care of anything inside of the bracket first. Inside of the bracket is just a single number, so we can skip that. The O for exponent. So I want to take care of that first. Then multiply and divide next. And 160 times pi is 502.6548 keeps on going. But let's go ahead. I'm going to take a quick look, and it asks for answers to the nearest tenth. So what I'm going to do here is I'm going to round up. So the volume is 502.7 centimeters cubed. Remember that, cubed, okay? And that's your answer for this one. Now, E, F, and G all look pretty weird, a little difficult maybe. So I'm going to go ahead and get you started, and then I'll give you a clue about what you should do at the end, okay? So here, again, we want to look for our radius and our height. So when I'm looking here, I see a radius of 6 centimeters, a height of 13 centimeters. So you should continue with your same equation here. However, when I look at this problem, I have a big piece missing. That is, if I were to take this, oh, duh, okay. Okay, if I were to take this and divide it, it divides evenly into fourths, right? So what that tells me is that when at the end of this, I get an answer at the end of this, I want to take that and multiply my answer by either 3/4 if you're comfortable working with fractions, or 0.75, because these are approximations of one another. And we only have 3 of the 4, or 3 of the 4 sections, so 3/4, all right? See if you can figure out the rest of that one on your own. Now let's take a look at E. Okay, so I'm sorry, E, F. Let's take a look at F. So I'm looking for my radius and my height. So when I look at this, now this is my diameter. okay? And I know that the distance here is the same as the distance here. So I know that my diameter is 20 centimeters. And my radius is always going to be half of my diameter. So that is 10 centimeters. And when I'm looking for my height, I know that it's going to be the same as this distance here, which is 40 centimeters. Again, I'm just going to erase this bit about the diameter because I don't really need it. Then this one, when I'm looking at the shape of it, I don't have my whole cylinder. It actually looks like it just got cut right in half. So similar to question E, once I get my answer, I'm going to multiply it by a number or a fraction. Can you figure out what that number or that fraction is? I have half the cylinder, so multiply it by 1/2, 4.5. But this one does go a little bit further. When I'm looking here, I'm not looking for the volume of only this. I also want to find the volume of this rectangular prism underneath. So then I'm going to have to take that out. And do you remember the equation to find the volume of a rectangular prism? We covered this on Friday. It is volume equals length times width times height. So once I get the volume for my rectangular prism, and I get the volume for I'm so bad at this. Okay, and I get the volume for my half cylinder. I want to add those two values together to get my total answer. Please don't hesitate to send me a message if you need help with that, okay? Okay, and lastly, for G. Okay, so when I'm looking at G, I have two cylinders for this one. So for my large outside cylinder, my radius for this one is 32 centimeters. And it has a height of 9 centimeters. Plug these values into that same equation that we've been using. You will get a large cylinder answer. Then we also have a small cylinder. So when I'm looking here, what this tells me is that the distance from here to here is 14. And so the radius for my small cylinder is, oh shoot. The radius is 14. My height is still 9. Use that same equation to find the volume of that inner cylinder. This will give you an answer for my small cylinder. Okay, so when I'm looking for the volume of that ring, what I want to do is take the volume of the large cylinder and subtract that inside space that is nothing. So I'm going to take my LC answer and I want to subtract my SC, my small cylinder answer, in order to get the volume of the ring. Okay, so that's the process I want to take. Please take a picture of all of your work and submit it and submit it to the Google form on ManageBack. Have a lovely day. Hope I get to see you soon. Bye guys, miss you.